Hello, class. I'm here to talk about the last problem for tonight, chapter 10, problem 80. Tomorrow I'll go do my best to go over problem 114 and also start with chapter 11, the chi-square, and go over as many problems as I can. Remember that I asked you to solve 9 problems total, and anything above that would be considered extra credit. So I'm doing my best to record as many videos as I can. Um, let's go over this problem right here because now we're still talking about the two means. However, if you go to your book, I jump here to, we have work on the two population means with known standard deviations, I believe on the last problem, but now actually they did a reverse on the problems, and now I'm gonna be working on a problem two population means with unknown standard deviations, and that's why I want to go over with you. Also, I want to tell you that it's getting to the point where calculating the t-test uh, and the p-value based on the t-test is getting a little more complicated. So I'm going to be showing you a Excel formula that I also put it on your discussion board on the discussion thread. I have added and please read that. And I'm going to go over here as well so you don't have to do all the calculations to get your p-value. The problem on your book is actually telling you to refer to Appendix E. So if you go to problem 80, it's gonna tell you right before, right here. Go to Appendix E. So that's where I was. We're gonna go to Appendix E, and in this case, we are working with a hypothesis testing with two sample means, correct? And then you're supposed to answer all these questions. You're not gonna, I'm not asking you to draw the graph. I guess you got the idea already when it's a right tail test, left tail test, a two tail test. So you don't need to sketch the graph for me. And also right here for the two, you're not going to be asked for the confidence interval. And also you don't need to put incomplete sentence, explain how you determine which distribution, because that's what we're going to go over here. And you really don't need length answer for that. So let's start with the problem. It says that at Rachel's 11th birthday party, 8 girls were timed to see how long in seconds 8 girls were timed to see how long in seconds they could hold their breath in a relaxed position. After a 2-minute rest, they timed themselves while jumping. The girls thought that the girls thought that the mean difference between their jumping relaxed time would be 0. Therefore, they are telling you that they think that the mean difference is equals to 0. Therefore, we're going to use the null hypothesis as equals and then the alternative hypothesis as different or not equal to. Just remember we're talking about mean. However, here we have two different set of data. That's why we're going to be using two different sample means, but we don't have it's an unknown standard deviation, so we're going to estimate the standard deviations as well. So your null hypothesis is going to be they're saying that the mean difference it's equals to 0. That's your null hypothesis. Therefore, if your null hypothesis is equal, then your alternative hypothesis is different. Well, in words, clearly state what your random variable represent. Your random variable is going to be the difference between jumping and relaxed time. So you can say that really let the random variable XD, the difference, right, um, is the average difference between relax and jumping times. Oh, and jumping time. Oops, jumping times. Okay. Um, well, that's the one that I said you don't need to put in complete sentence. Which distribution to use for this test? You don't know the standard deviation. You do not know the standard deviation, and you also work with a small sample, but that's not the case. Therefore, the fact that you don't know the standard deviation, you're working with the, you can call it a student t distribution. Since your sample size is 7, then your degrees of freedom would be is 8. Actually, your degrees of freedom would be 8 minus 1, which is 7. I'm sorry, uh, confusing you a little bit. Okay, there we go. And where's my test statistic? Well, this part here might look a little more complicated, but really you just need to follow what you're using before. On the last problem we use it as well. So let me go back here, um, right there. We're just gonna be using this. Okay, let me see, maybe I can put it over here. Okay, good. So let's see if we can do that and get it, all the values right before I'm getting ahead of myself because I haven't defined well my sample size. I just said is 8, correct? Therefore, my degrees of freedom is going to be 8 minus 1. Okay, here my x bar or my sample mean for the first data, I can just go over here and do the average of these numbers right here, and it's going to give you the average. So you don't need to do a lot more calculation. Now we're going to do the sample mean for the second set of data. So we're going to do the average of these values right here. Now the standard deviation, remember you're working with the sample. So we're going to do ST dev S for the sample, correct? Standard deviation of my sample, and I select these numbers as well. And then right here, I'm going to do the same thing, but I'm going to do for the second set of data right there. And my t-stat is the one that I'm going to start working on it right now. Look more confusing is going to get, so the best way I found it is for you to do the difference of these two values right here. So do the difference of the jumping time and then the relaxed time, and you can drag this down. You just, again, how I did, I just see how it turns into a little black cross, and I drag it down so it copied the formula down. And now I'm gonna square this value. So here we go, raise to the second power. And again, I can just do like this, or I can drag it down. It really doesn't matter. What I want to do, I want to sum all these values right here. And which is minus 14. I knew here was wrong. This sum would be 100. If you want to go ahead and sum this as well, that's fine. And you can even continue with the standard deviation, which you already calculated over here. That's why I'm not redoing. So the best way now for you to get your t stat is by using this formula. Believe it or not, This would be the simpler way that I found it. Right here, I'm talking about, and I'm gonna do one by one actually. I'm talking about the sum of your difference right here. See the sum of your difference? And I'm also gonna refer to so this is difference square. And here is the sum of the difference square. Sum of the difference square. Here's your sample size, sum of the difference square, and then the sample size minus 1. So we're going to do one by one, okay? This value, I'm not doing the square root yet. I'm just doing this value minus this value. So 800 minus 196, correct? And then now I'm going to divide these two formulas by my n minus 1. So I'm going to do 604 divided by 7. Okay, now I'm going to square root this value. Now I'm going to square root everything. I did one by one. I did this, then I did this, then I did this. Then I did this formula, this equation, and this part right here. Now I'm squaring root. I guess that's how you say it. The bottom still on the denominator, which I got this value over here. So now remember, on your top portion, you have the sum of the difference. So you have the minus 14 divided by this value over here. And you should get test statistics of minus. So you t stat of minus 1.51. And now that's where I'm going to be showing you the little formula that, let me put it here as well. The little formula that I told you I would be sharing so it can make easier on you to find the p-value. So let's go ahead and calculate the p-value. The p-value, all you need to do here, you have a t-distribution for a two-tail problem, correct? Equals different two-tail over here. So all you have to do is equals, and then start typing t. There you go. You're showing lots of formulas. See right here, a t-distribution for a two-tail. A t-distribution for a two-tail. Here means a t-distribution for a right tail, and then right here would be inverted, the other side of the table, the negative side. So we're going to be using for 2. The x here, it's really what you just calculated, your t-stat. So remember that Excel, or keep in mind that especially in this formula, Excel is not gonna understand the negative. Okay, so again, type T, which you could put an invert, but then it might get very confusing if you're not used to Excel. So let's put a T distribution for a two-tail, where right here, just do 1.51. Don't put the negative side. Remember, we're looking at both tails of the curve, because it's a two-tail, right? Your degrees of freedom, you're gonna have 8 minus 1, or you could just type 7 and then you enter, and there you go. Or if you type 7 is the same value. Uh, if you refer to this cell, you're gonna have a little difference, because remember, you should have more digits. Right here, I just type it, but over here, if you would refer to the actual result, you're gonna have way more digits, and then you would find something different here. So let's see, let me show you if you would use the formula by referring, which in this case, you could not refer to the cell because it's a negative. Okay, so you actually would have to use an absolute value. So let's just leave it that, so it doesn't get more confusing. Okay, let's leave at your p-value for a two-tail. It has already calculated for you for a 2. tail. Okay, so you don't need to multiply or nothing like that. Alpha, you were not provided an alpha, therefore your default is a 0.05. Okay, and then let's go ahead and bring our little rule down here so we can make our decision. Well, if your p-value is 0.05 and you have just figured that your if your alpha value is 0.5, 0.05, and you just figure that your p-value, which I should write it right here, it's 0.1748, that's 17%. Therefore, your alpha value is less. It's less than your p-value, correct? Which is 0.1748, correct? So if you have an alpha value less or equals than your p-value, then you do not reject the null hypothesis. Therefore, your decision is do not reject the null hypothesis. The reason for decision is because either the alpha is smaller than the p-value, or you can say that the p-value is greater than the alpha. Conclusion, well, we are using a 5% default, correct? And right here is saying that the mean difference is equals to 0. So at the 5% level of significance, there is insufficient evidence to conclude that the average difference is not 0. So we reject the null hypothesis. Therefore, we are saying the alternative hypothesis that is actually different than 0. So there's nothing, we don't have anything to conclude that the difference is not 0. And then you would be done with problem 80. Again, you're not going to be seeing the problem again, but I want to go over. And the reason is because if you're not used to Excel, or if you don't know how to use a calculator, or anything else that you can use to calculate your t-statistics, the degrees of freedom for the two sample means with an unknown standard distribution, standard deviation could really confuse you. But I really want to show you that we can go ahead and also change a little bit in a way that we still can get the results we need. And that's all for tonight. I will try my best to do 114 tomorrow, which is for proportions. Start with chapter 11 with the chi-square. So we can finish chapter 9, 10, and 11 by Sunday, and begin next week with linear regression.